Linear programs, examples and non-examples. So remember the optimization paradigm. For linear programs, we need decision variables, we need an objective function which must be linear, such as minimize cost, maximize expected return, make the last semester as enjoyable as possible. And we need constraints, which are either linear equalities or inequalities. We're permitted to use greater than or equal to, and less than or equal to. We cannot use greater than or less than with strict inequalities. So here are some examples of linear programs and some non-examples of linear programs. Maximize x subject to x greater than or equal to 10. Linear program. Not a linear program if you replace it by a strict inequality. Maximize 1 plus 2x subject to x equals 1. That's a linear program. Maximize 1 plus 2x squared subject to x equals 1. Not a linear program, even though you know exactly what x is. Still not a linear program. Minimize 5x subject to x less than or equal to 10, x greater than or equal to negative 10. Linear program. Minimize 5x subject to the absolute value of x less than or equal to 10. Not a linear program, even though it has exactly the same feasible region as the linear program on the left. Our last example and non-example, maximize y subject to w equals 1, y less than or equal to 10. It's one with two variables. It's a linear program. Maximize y subject to w equals 1, w times y less than or equal to 10. Okay, even though we know w is equal to 1, it's a variable, and we can't have variables times variables in a linear program, so it's not an example. Okay. It's important to remember you cannot decide whether an optimization problem is linear without looking at its form. Okay. It's not enough to know what the feasible region is. It's not enough to know that it can be made into a linear program. It's got to be one at the beginning. So on this slide, the one on the left, linear program, the one on the right, it's not. Okay, those are the rules for linear programs.